Okay, so this is a tasty question. It's a 7 marker. It's towards the end of the paper, so there's an indication this is going to be a tough question. So when we look at the left-hand side, the clues, we've got one bracket to the power of 4, and then we've got another bracket to the power of 3 exponent 3. So it feels like we're going to do a binomial expansion of both brackets, and then we have to times them together. But I don't think we need everything multiplied together, okay, because that could take way too long. So we've got to be careful with our expanding. But because it is 1 plus x to the 4, it feels like we could expand all of that and just get the first, all 5 terms. And 1 plus px to the 3, there's only 4 terms there. So I think in this case, it makes sense that we just expand and get all the answers. So if this is only a 4, this is a 3, it won't take long to actually expand and get all terms. Now, if this turned into a 7 or 8 or 10, and this was a 5 or 6, then it makes no sense to expand and get all the terms. So let's just go ahead and expand and see what happens. So the first one is 1 plus x to the 4. So I will do it the long way. 1 to the 4, 1 to the 3, 1 to the 2, 1 to the 1, 1 to the 0, x to the 0, x to the 1, x to the 2, x to the 3, x to the 4, and now 1, 4, 6, 4, 1. Can you see how handy it is just to know those numbers from the triangle? So this is actually just 1 plus 4x plus 6x squared plus 4x cubed plus x to the 4. So in fact that simplifies really nicely, right? 1, 4, 6, 4, 1, and then just the x in increasing exponent. That's always under the case. If there's a 1 for the first term here, can you see this 1 powered up just doesn't affect the overall answer. Let's do the same now for the 1 plus px to the 3. So I'm going to do it a slightly different way from the triangle. 1, 3, 3, 1. And as I said before, the first term is a 1, so that won't really play into the final answer because it'll just be powers of 1. So I'm only going to focus on the px here. In this first term it's going to be px to the 0. In this one it's going to be px all to the 1. In this it'll be px in a bracket squared. In this one px in a bracket cubed. Let's tidy up. Alright then, so I'm going to write those out again. 1 plus 4x plus x, 6x squared, plus 4x cubed, plus x to the 4. So it's that, but we're going to multiply it by the 1 plus 3px plus 3p squared x squared plus p cubed x cubed. Now I've written them underneath each other because I think it's easier to start to think about what's going on. Now ultimately the final answer to this is going to be quite a long thing because we need to take the 1 here and times it by 1 and then this and then this and then this. There's 4 answers we write down. Then we take the 4x, we multiply it by this, 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 this. We write down 4 more answers. This times by this, 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 this. Write down 4 more answers. So we'll have 4, 8, 12, 16. We'll have 20 answers down here. Some of them we will be able to gather together because they'll have like terms. They're the same sorts of x's, x squareds, x cubes, x to the 4s, and then it will simplify a lot. But as we go back to the question, we now need to focus and be smart and think about, well, what are the clues from the answer that will help us? So notice we've got a qx, we've got a 69x squared. So let's go and look at those, where my x's come from and where my x squareds come from. Okay, so that's the clue. Let's go back now down to here. So you've got to think, if I take this 1 and multiply it by some of these guys here, where does x come from in the answer? And you can see clearly, I think, that if I do 1 times by the 3px, I'm going to get some x's coming out. And that is the only way I'm going to get x's coming out. But now also, can you see, if I do the 4x here times by the 1, I'm going to get x's coming out. So let's go ahead and do that. So 1 times by 3px plus the 4x times by 1, that'll give me x's, but we know that has to be equal to qx. So this is just going to be an equation we can set up that says that if I tidy all this up now, this is, if we take out a factor of x, this is 3p plus 4, and this equals to qx. So this tells me that the 3p plus 4 has to match the q, right? Because we have the same amount of x's. This is going to be equation 1. And now let's think, using a different pen, I think, we've got to think about the 69 x squareds here. Right, so where do we get x squareds coming from? So 1 times by the x squareds, that will give it. The 4x times by the 3px will give x squareds. And the 6x squared times by the 1, that's going to do it, right? So let me just get maybe a green pen. We'll do the same one. So this guy times this guy times by this guy, and this guy here times by this guy. Okay, so we just have to be careful. You can see it's a long question, but it's a 7 marker. It's towards the end of the paper. It is a tough question. So let's write that down. So we've got 1 times by 3p squared x squared plus 4x times by 3px plus 6x squared times by 1, and that has to give us the 69x squared. So there's a common factor of x squared on the left hand side, so I'm going to go ahead and take that out already. Then I've got 3p squared plus 12p, I believe, yep, plus 6, that has to equal to 69x squared. So can you see that actually I've got a quadratic to solve here. I've got 3p squared plus 12p plus 6 has to match the 69. So let's put in a new page. 3p squared plus, what do we say, 12p plus 6 equals 69. Tidy up. Okay, usually before you go ahead and factorise, you can divide through by a constant. Remember, you can't divide through by a variable, but you can divide through by a constant. That will make the factorising definitely a lot easier, because this factorises with 3 and 7, I believe. So either p equals -7 or p equals 3. Let's go back and look at the question to see if there's any restrictions on p and q. Find the possible values for p and q. It doesn't really say anything in the question. And if you think about it, p is just how many x is here, so it feels like it could be positive or negative. It won't have an impact in the overall answer. Okay, and then notice I highlighted this equation 1 here. This was a link between p and q. So once we found p, we can find q. So let's write down this equation. 3p plus 4 equals q. Okay, so if p equals to -7, we can say this implies that 3 times by -7 plus 4 equals to q. Therefore, q equals to -17. So we have pq equals to -7, -17. And of course, if p equals to 3, then this implies we have 3 times by 3 plus 4 equals to q, and q equals 13. So we also have pq is equal to 3, 13. Ooh, so it's a tough question. It's a long question, but you can pick up method marks all over the place here. You know, if you expand here and expand here, I think you'll have kind of at least 2 marks just for doing something that's quite easy. Then it's the thinking at this stage that gets you the marks, I think.